today by doing geometric proofs using our properties of algebra. We did algebraic ones, and we solved equations and did slope-intercept form from algebra class and used the properties to help us set up a statements and reasons 2-column proof to kind of help us when we do geometric ones, okay? So make sure you have your little handout out with all of your properties. I'm going to have me a copy out too. So a proof is a logical statement that shows that a statement is true. Okay? So what's going to happen is they're going to give you some information about a topic, about a scenario, and then they're going to ask you to prove something or determine something or to show something. Okay? So a proof is how we do that. The way that we set them up in high school math is called a 2-column proof. That's when we have our set of statements and reasons. So it's going to follow the format we did yesterday for algebraic proofs. Okay? Got it? All right. So here's our first ever geometric proof. Draw the picture. Pictures are very important. Pictures are important. It always helps to draw the picture and to label your picture. Mm-hmm. I like those because they're smaller. All right, so I've got one big angle that is split into 3 little angles, angle 1, angle 2, and angle 3. Do you see this little red mark for angle 1 and angle 3? So what does that mean? Yeah, they're congruent. They have equal measures. Y'all see that? Okay, so tick marks on a segment are the same thing as these little arc marks in an angle. They mean they're congruent. Okay, so the picture is telling me that angle 1 is congruent to angle 3. So that's really what that picture is giving me. And I'm trying to show that the measure of angle EBA, which is this angle 2 and 3 together, is the same as the measure of DBC, which is the same thing as 1 and 2 together. So I'm trying to show that this one is the same as this one. Okay? So we're going to set up our table with statements and reasons. Just like yesterday. Statements and reasons. If I could spell reasons. Yes, that's the whole point. You have to have a reason for every statement you say. Okay, you have to have some kind of evidence. That's your evidence to why you can say the statements. Okay? So my first statement is what they told me in the picture. The measure of angle 1 equals the measure of angle 3. And that is given. And I'm going to put in parentheses in the picture. Because they didn't really tell me in words, but it's in the picture that they are marked congruent. All right, is everybody good so far? So I've got to somehow get from here to proving that measure of angle EBA is equal to the measure of DBC. Okay, so this first reason is always given to you, either by a picture or they say it in words. Okay, so angle 1 is congruent to angle 3. So know what I can say? I'm trying to prove that EBA, this one, from here to here, 2 and 3 together, is congruent or equal to the measure of angle DBC, which is 1 and 2 together. Y'all with me? Okay, so how do I get the measure of angle EBA? What 2 things make up EBA again? Yeah, so the measure of angle 2 plus the measure of angle 3 equals the measure of angle EBA. And guess what tells us that? Something we learned last chapter called the angle addition postulate. So you can use any theorem, definition that we have covered, you can use as a reason. I can't spell postulate. So y'all remember that angle addition postulate from chapter 1, little angle plus little angle equals big angle? Y'all remember that? All right. So likewise, how could I get the measure of angle DBC? Well, here's DBC. What two angles make that one up? 1 and 2. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle DBC. And that was also the angle addition postulate. You're right, I did tell you you couldn't say sub because we did have substitution yesterday. Sorry about that. I asked y'all and y'all didn't say. It was on the sheet. Not well. Hang with me for a second. So we kind of just put those things together based on stuff we already knew, right? So here we got to do a little bit of logic. That means we have to use our brains. This space between our ears, this matter that everybody has, or you wouldn't be able to breathe or talk or walk, is called a brain, and we all have one. Size doesn't matter when it comes to brain. All right? It's content and knowledge. All right. So think with me real hard. What do these two things have in common? Or you can look at the picture. Not lines. They both have angle 2 in them, right? Right? Okay? So they both have angle 2 in common, right? And if you look at the picture, EBA has angle 2 in it, and DBC has angle 2 in it, right? They both have that angle 2 hanging out in the middle. Y'all see that? Okay, so I can do something there. What did they tell me from the beginning? Angle 1 and angle 3 is congruent. Now there's some kind of property that tells me that if two things are equal, I can replace one with the other. It's substitution. Yes. Anytime in math, two things are equal value, you can replace one with the other. Okay? That's called substitution. So, since angle 1 and angle 3 are congruent, looky right here. Can I substitute one for the other? They're congruent, equal measures, so I can replace one with the other. Okay? So right here where I have an angle 1, can I put angle 3 in for it? Yes, I can, because they're equal. 1 and 3 are equal. So now I can say, where this is angle 1, I can change it to say the measure of angle 3 plus the measure of angle 2 equals the measure of angle DBC. So all I did was take this line and replace 1 and 3 because they're congruent. So I use the substitution property. Okay. So this line looks exactly like something else, just about, right? Do we have another line that says measure 3 plus measure of angle 2? Do I have something else that says that? This line right here, right? They're in a different order, but they're saying the same thing, right? So this one says angle 2 plus angle 3 equals EBA. This one says measure of angle 3 plus angle 2 equals DBC. So if they both equal the same thing, then they can be equal to each other. That's called the transitive property. If two things equal the same thing, then they equal each other. It's on your sheet. Okay? Transitive property is on your sheet. If two things equal the same thing, then they equal each other. Okay? So, if I have 4 quarters, that equals what? $1. What does 10 dimes equal? $1. So say I go to pay for a candy bar at the ball game and it costs $1. Could I pay with my 4 quarters? Yeah. Could I pay with my 10 dimes? Yes. So could I say that 4 quarters equals 10 dimes? Yes. Because if two things equal the same thing, then they equal each other. That's called the transitive property. You need 3 things for the transitive property. Two things equal the same thing, then they equal each other. So, my last step would be, since this and this are the same, then these two things equal each other. They both equal the measure of angle 2 and that measure of angle 3. So then I can say those two angle measures are equal. Okay? Because if this equals this and this equals the same thing, then these two things must equal each other. You are going to have to learn your properties and practice these. How are you good at anything? You practice it. Well, that ain't going to happen. And that's called the transitive property. Two things equal the same thing, then that will be equal to each other. Now, y'all, how are we going to get good at this? We're going to practice this. Now, y'all's minds are probably spinning 50 different directions in your head. Can I make a confession? When I was in 10th grade and I was taking geometry and I first saw my first geometric proof, guess what? My mind was going, oh my gosh, I'm going to fail. I've never made a before in my life. How am I going to do this? I got to make that. Wrong thing to do like that. Yeah, I was a nerd. Still am. Okay. But y'all, we're going to see enough of, this is not on your quiz Friday. This is not on your quiz Friday. All right? All right? This is not on your quiz. It'll be on your chapter 3 test, but it's not on your quiz on Friday. All right? So this is why we practice it and get slowly into it. And guys, even like on your homework tonight, you're not going to do a whole proof by yourself. You might have to fill into a certain part of it, but I'm not making you do a whole proof from scratch just yet. We're going to get there. All right? It's a marathon. Now, you ain't trying if you're on your phone. I'm tired of it. That's twice already. I've caught people on their phones that are paying attention to me and you've never done a geometric proof before in your life. That's got to stop right now. All right. Next one. All right, so let's just look at those other proofs on that page. Reflexive. Let's just go over reflexive, symmetric, and transitive. Reflexive means anything equals itself. That's pretty easy. It's like looking in a mirror. Okay? So anything equal to itself is reflexive property. Now, we won't need that just yet. We'll use a lot of reflexive property when we're talking about triangle congruence. Okay? So we won't use a lot of reflexive property just yet. Symmetric means you can swap the order. If C equals D, then D equals C. You can swap the order. That's what symmetric means. And then transitive, we already went over. If two things equal the same thing, then they equal each other. Okay? So let's draw this picture. Now this one's kind of backwards of the one we just did. Okay? The one we just did, we were proving that the two angles put together equaled each other. This time we're proving that these two little angles equal each other. So it's like exactly what we just did, only in reverse. Okay? So this time we're proving the two little angles equal each other. Last time we proved two big ones. This time they're giving us the big ones are congruent. We're proving little ones are congruent. So, statements and reasons. Now, y'all, what it says, show that or prove that, that will be your last statement. That's how you know you're done with the proof, if you prove what they're asking you to show. Okay? So that will be your last statement. And when you get there, that's how you know you're done. Okay? But did they give me something important that I can say is my given? Well, they did it twice. They did it in the picture, and they told it to me in black and white, didn't they? Y'all see this right here? Oops, I just meant to highlight that, and I did not do it. Stop it. That. Y'all see that? So that's my given. The measure of angle ABD equals the measure of angle CBE. And that's given. And they've already marked that on my picture for me. ABD, which is 1 and 2 together, equals the measure of CBE, which is measure of angle 2 and 3 together. See that? Okay, so I'm going to start from there. So, what two angles make up ABD? So likewise, I can split that up. The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABD. Now, which postulate or theorem tells me little plus little equals big angle? Angle addition postulate. Okay? So y'all tell me what my next sentence will say, or my next statement. So we're going to do the same thing now for angle CBE, right? What two little angles make up CBE? 2 and 3. So the measure of angle 2 plus the measure of angle 3 equals the measure of angle CBE. So that was also the angle addition postulate. Okay. Don't we already know that these two things are equal? Look up here, y'all. Don't we know that these two angles are already equal? Because we told that in our first statement that was given to us, right? So, substitution says if two things are equal, we can replace one with the other, right? So, where this one says CBE, since it equals ABD, can I put this right here? Since we already know these two things are equal, right? Right? So, that's what I'm going to do now. So, I'm going to say this equals this because of substitution. These two things are equal, so whatever they're equal to, I can put in its place. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And that was substitution. Okay? So these two things are equal to each other, so I can replace this with this. That was substitution. If you replace two things that are equal, it's called substitution. All right, now look real careful. What do I have on both sides of the equals? Measure of angle 2. So if I subtract that on both sides, what happens? What happens? They cancel out, don't they? Right? And I can do that because it's an equation and I can do the same thing on both sides of an equation, right? So I subtracted it on both sides. So they cancel out. Now I'm left with the measure of angle 1 equals the measure of angle 3. Is that what I was trying to prove? Yeah, because it said show that the measure of angle 1 equals the measure of angle 3. What was the last thing I did? I subtracted. And that's how I know I'm done. If what I proved is my last statement is what I was trying to show or trying to prove. That's how you know you're done. So, the first statement is what they tell you. The first reason is always given. So there's two things already done for you. And your last step to every proof is what they tell you to show. So there's three things in every proof given to you from the very beginning. Okay? So you should never, ever have a blank proof. Ever, ever, ever. Because you can always do the givens and the statement. The last statement. All right, we're going to skip a few. Can we skip one? We're not ready for that yet. Write this down. We're going to take a little break from proofs for a second and talk about some of these properties. Give y'all a little brain break. This is heavy. I ain't gonna lie. I ain't gonna say it's easy. It's difficult, especially today. It is first time you've ever seen it. I mean, honest, y'all are in the shock factor right now. I mean, yeah, we're gonna do the same. Once we learn parallel properties, we're gonna apply it to parallel lines. Once we learn triangle congruence, we're gonna prove it's triangles. So we're gonna have to do it and build on it. But y'all are just now getting the logical steps on how they work. Okay, before you can say a statement, you have to have a reason, a concrete property. Or it just says right here, a reason can be any definition, property, postulate, or theorem. Okay, so that's why it's so important to know our terms, to know our vocabulary. Okay, it's so important to know. Because sometimes, like if I say the word bisector, that could be a reason, the definition of an angle bisector. Okay? Okay, so what's the difference in like a theorem or a postulate or something like that? A theorem is a statement that can be proven. So if it can't be proven, it's just a rule, we call that a postulate. If it can be proven, we call that a theorem. So like something y'all have heard of, the Pythagorean theorem is a theorem. It's been proven backwards and forwards for many, many, many years. Okay? All right. This is on page 113. But we've just talked about three major properties. And they're on your sheet. The reflexive property, symmetric property. Is that two M's in symmetric? And the transitive. Okay, so let's just quickly go over those three. Reflexive means anything can be equal to itself. Symmetric means you can swap the order. Transitive means if two things equal the same thing, then they equal each other. Okay? So here's two examples right here. And it's got some symbols in it. Right? And I told you on our quiz, we're going to have to know our symbols. So, what is this little symbol? Looks like a slanted L. What's that? Angle. What's this symbol with the equal sign with the squiggle on top? Congruent. What does congruent mean? Equal measures. Okay? So, tell the property that is illustrated. So, this first one says if angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. Now, which property says if two things equal the same thing, then they equal each other? Transitive. Okay, here's my little clue for transitive. Transitive starts with a T. You got three different things you're comparing. R, T, and P. 3 starts with a T as well.
So if it's 3 different things, it's always transitive.
Not necessarily, but a lot of times, yes. For these three properties, yes, you'll have to have 3. If you have 3, it's transitive. You have to have 3 for it to be transitive, but it's not always transitive when you have 3 things. What you said was true, but your converse is not true. There we go. There's some geometry. The next one, what's this symbol mean? segment NK is congruent to segment BD, then segment BD is congruent to segment NK. So what happened there? They swapped the order, right? They said NK first here, and then they said BD first here. So which one says you can swap the order? Symmetric. Does that make sense? All right. I want y'all to open your book to page 113, and I want y'all to do 2 of those. Something equal A equals A, or the measure of angle 2 equals the measure of angle 2, or line segment BC equals line is congruent to line segment BC. Anything equal to itself or congruent to itself. So page 113, the bottom of the page where it says guided practice. Tell me, write down real quick. Don't say it out loud yet. Tell me which property of those 3 do you think it is? Now this is what the majority of your homework is going to look like tonight. Not so much proofs. Tell me what property is used on number 2 and number 3 at the bottom of the page. So you're just writing down one of those 3 words. Those 3 on my board over there. Well, you know, are we that lazy? We're not writing RS and T. You gotta give me more than a letter. Check them with a neighbor when you're done. Reflexive means it's equal to itself. What's up? Yeah, set it upright in that garbage can, because they'll clean mine after. Just make sure it's upright. Okay, so y'all answer me out loud, please. Number 2 says segment CD is congruent to segment CD. Which property says that anything is equal or congruent to itself? Reflexive. Raise your hand if you got number 2 correct. Symmetric means you swap the order. So look at 3. 3 says angle Q is congruent to angle V, then angle V is congruent to angle Q. So you see how they swap the order? So what is that one? Symmetric. Raise your hand if you got number 2. Number 3. All right. So use your handout. It has examples on there for you of angles, segments, and anything else, okay? They're on there on that handout. All right. Let's do a few more proofs to round it out. Let's do one with numbers. We haven't done one with numbers. It says you try, but we're doing it together. Ignore that. I'm not ready to turn y'all loose yet. You ain't ready. Be like me throwing you out in the ocean if you don't know how to swim. Say, oh, you'll learn. Right? That's how my dad taught me to swim, but I wasn't in the ocean. I was in the pool. Yep. I don't remember not knowing how to swim. My babysitter had a pool, and so I could swim it too. Okay. So y'all write that down. I'm going to go ahead and set up statements and reasons. Please draw the picture. It's on the screen. Oh, this one's easy. It's easy. All right. Statements and reasons table. What's given to me? They gave me two things, didn't they? Yeah. They told me, first of all, that the measure of angle 1 plus the measure of angle 2 is 90 degrees, which is a what? Right angle. That's given to me. So, y'all, on your book, sometimes they have it just all at once, like that. Oh, we're proving that. Sorry, I lied. They tell me the measure of angle 1 is 59. So, what sometimes they'll give you two givens. All right? And I'm okay if you combine those into one thing for given. But I'm telling you, the book likes to do two givens if it's like that, if they give you more than one thing. Okay, so you can have two givens. All right, y'all okay with how that's given to us? Everybody's starting off there. Okay, I'm going to let y'all think about it for a little while. What do you think we can do? Say it again. Plug it in. What's another word for plug it in? Substitution. So what are we plugging in, Trey? Yeah, they tell me that the measure of angle 1 is 59 degrees. So if I have this equation right here with the measure of angle 1 in it, I can substitute 59 degrees there.
Wait, why are you so?
Because if two things, this equals angle 1, then I can replace it.
Wait, but what are you trying to like figure out?
I want to find out, I want to prove that the measure of angle 2 is 31 degrees. I'm getting there, but you got to do it in a proof form. Essentially, yes. But first, I have to substitute 59 degrees into the measure of angle 1. Okay. Sometimes in a proof, we have to list the obvious. Okay? You just can't jump to it. You have to show your steps and list the obvious. Okay? So, yes, I'm going to replace that right there. So now I can say 59 degrees plus the measure of angle 2 equals 90 degrees. And I use substitution there. Now what would I do? Now subtract 59 degrees. You're right. And so now the measure of angle 2 equals what? 31 degrees. Is that what I was trying to prove? All right, I just need my last reason. What was the last thing I did? Subtraction. So Zane, you are right. We just got to list out our statements and reasons while we do it. Got it? Got it? And we had to start by, we knew what the measure of angle 51 was, so or angle 1 was 59 degrees, so we had to substitute it there. And we do this stuff all the time. We just don't call the properties that we're doing, right? We've done that in math class lots. We've substituted our whole lives, y'all. Okay? We just got to start in geometry. We have to logically explain our steps. Okay? It's like going to court. Okay? If you're going to prove that somebody murdered somebody, there's steps. You have to prove this part. You have to, number one, prove that they were there. Then you have to prove this. Then you have to prove the evidence. Okay? So it's kind of like that. You have to justify everything you say while you're doing a proof. All right, let's talk. We haven't done any with line segments yet. So we've all done proofs with angles. Now we're going to do just a couple. Y'all, when I say a couple, that means two. Okay? So we got two more proofs to do with line segments. Y'all can whine. That just makes me talk longer. That's fine. Well, y'all don't have very much anyway. You don't have any anyway. I said you don't have much. Yeah. I told you you're not doing a whole proof by yourself. Can you just let me do the problem? You've got a lot of telling if it's reflexive, symmetric, or transitive. Okay. Y'all just making it longer talking. All right, everybody have this on the paper? Okay. So, okay. This is what we're trying to prove. Now, what does this mean if I have two letters squished against each other in a segment? That means what? The length of it, right? That's how we show measure of a segment. If we don't have a bar over it, that means the measure of it, okay? So we're trying to prove that the length of segment RS equals the length of segment 2U. Alright? So I'm proving that this little segment equals this little segment. Now, what's my given here? Say it again. No, that's what I'm proving. What is given to me? Look at the picture. Try again, you're really close. TU. Nope, that's what I'm trying to prove. What's given to me? Noah. Well, you can even shorten it to R to T and S to U. Right? Right? What do these little symbols mean? Yep, little tick marks mean congruent. Okay? So, statements and reasons. My given from my picture is that the length of RT equals the length of SU. And that is given from the picture. That's what the little tick mark means. This and this. Okay? Y'all with me? Okay. Now, you know how we used the angle addition postulate a while ago to put things together? Well, we also had the segment addition postulate for line segments, right? So, what makes up RT? RS and ST. So, I can say that. The length of RS plus the length of ST equals the length of RT. And that is the segment addition postulate because these are line segments. So likewise, what can I say about the length of SU? What makes up the length of SU? That's right. ST plus TU equals SU. ST plus SU equals SU. And that is also the segment addition postulate. Okay? So y'all, we're doing the same thing with segments as we do with angles, basically. Okay? Now, what? So, they gave me that these two are congruent, right? Right? So, can't I substitute then? Right? So, if these two are equal, then can't I replace this right here? Did I do something wrong?
How is SU equal to SU plus something? Yes, TU.
It is TU. I'm sorry. Thank y'all, young brains. Sorry, change that S right there to, SU can't, and plus something can't, that's not mathematically possible. Thank you. Change that to a T. Okay, so like I said, since these two are equal, that means these two things are equal, right? So I'm going to use substitution to tell me that ST plus TU equals RS plus ST. So that was substitution. I think this is just like our second proof we did. Now, what do you see on both sides of the equal sign we can get rid of? ST is on both sides, right? So how can I get it to cancel out and go away? Subtract ST. And they cancel on both sides. So now TU equals RS because of subtraction. Now, is that what I was trying to prove? Look careful. What's wrong with it? It's backwards order. Well, what property says I can swap orders? Symmetric. So now I can say RS equals the length of TU because of the symmetric property. That was kind of long. Now, if I'd have rewritten it like that, I wouldn't have had to do the symmetric property. Correct? How are we going to get good, y'all? Practice, practice, practice. This Friday, but not on this. It's not a test, it's a quiz. And it's on the board. What it's on? All right, can we do one together? Do y'all want to stop writing and just help me use my brain? Can we just use our brains and y'all let me write? Okay? Because I think that might help y'all just to see it in place so y'all can kind of help me decide what to do. Okay? Y'all, this is practice. This is practice. Everybody take a deep breath. This is not on my quiz Friday. Say it. This is not on my quiz Friday. Repeat it. This is not on my quiz Friday. I am so chill. Okay, statements and reasons. What's given to me on this picture? Try again. Look for tick marks. AB equals CD. Look at your tick marks, okay? Okay. And they told me that too, didn't they? No, I'm looking for tick marks to say that something's congruent. I'm trying to prove that AC equals BD. So that will be my last statement. I don't see everybody's eyes up here. Okay. So I'm trying to get to something about AC. So y'all tell me what I can say about AC. It's AB plus BC is AC, right? So AB plus BC equals AC, which is what postulate tells me that? Segment, addition, postulate. Okay. Likewise, tell me something about BD. How do I get BD? BC plus CD equals BD. Same reason, right? Segment, addition, postulate. Okay, now let's play around with those equations for a little bit. Okay, start with what they gave me. What can I say? AB equals CD. It sure does. It tells me that, right? So that means anywhere I see an AB, I can replace it with a CD, where I see an AB right there. Right? Right? So can I change this AB into a CD? So I'm going to. So I'm going to copy that same row, except for where they have AB, I underline it. I'm changing it to CD. And that was substitution, right? Now look carefully. Isn't this and this the same thing? BC and CD and BC, yeah, they're the same thing, right? So if two things equal, if this equals this and this equals the same thing, then I can say what? Not reflexive. Transitive. It's transitive. If two things equal the same thing, they equal each other. So now I can say this equals this because of the transitive property. Y'all see that? Because these and this is the same. Mathematically, it's the same. So now I can say those two equal each other. Y'all are getting it. Y'all think y'all are like fed out to the wolves to die in the cold. But y'all are doing great. This is like very encouraging to me. See, look. Good. I'm so proud of you guys. Okay, now y'all look. Okay. Page. I want you to go ahead and open to page 116. Page 116. Ignore that crap. Okay. Everybody look on page 116. I was over my goal by 3 minutes. Sue me. Sue me. We did some. Hey, I took off 3 minutes working y'all's homework problems, so there you go. Okay. So y'all look here. Are y'all on page 116 with me? Look at that number 3. Y'all see that? All you have to do on number 3 is fill in one blank. You see that one blank? Y'all see that? Uh-huh. So you just tell me what property or what definition or whatever you think happened there. Oh, there's 4 too, right? Well, okay. Isn't 4 the last statement? So isn't what you're trying to prove supposed to be the last statement? Number 3, problem number 3 has a blank on number 3 for a reason, a blank on number 4 for the statement. Okay, so that number 4 on number 3 statement should be AC equals 11. Y'all see that? So the last statement should always be what you're trying to prove. Number 4 is multiple choice. You're filling in that last reason, and it's multiple choice. Y'all see that? Okay. Then when you get to number 5, you use the reflexive property to fill in that blank. So what does reflexive mean? Equals itself. So what is congruent to segment SE? Segment SE. Right? Does that make sense? So on number 6, you use the symmetric property to say something. But look, it told you that angle RST is congruent to angle JKL. So what does symmetric property mean you do? Swap the order. So you swap the order to do number 6. Number 7 says transitive property. You're filling in the blank. If 2 things equal the same thing, then they equal each other. So figure that out. 8 through 12, you're just telling me what property it is. 12 is multiple choice. Number 18 is another where you try to fill in the blank to finish the proof. Nope, number 18 is a whole proof. We're erasing that one. Don't do number 18. And then I want you to try number 21, which is fill in the blank proof. Got it? Sound good? Try. That's all I ask you to do is try. It's possible you can start right now. Yeah. And most of it's reflexive symmetric. Let me sign it. Bring it here, please, ma'am. So you don't have to draw a whole proof or anything. All right, we're not going to get there if we are running our mouth. So I want to see everybody working and get it done. 2.6. And I did not stop recording. Have a good day.